Okay, so we're going to move on to section 2.5, which is called equations of lines and linear models. So there's three different ways that we could write an equation of a line, three standard ways. One way is called point slope form. And the equation for this is y minus y1 is equal to m times x minus x1, where our point is going to be x1 comma y1, and then our slope is always m. Now sometimes people get confused with this. Sometimes they put the x and the y's in the wrong spot. So let me show you a way that we can remember this. Remember the equation for slope, it's just y minus y1, or you subtract the y values over you subtract the x's, right? That's the equation for slope. Well, if you want to get rid of the denominator, we've talked about this before, you can multiply by that denominator and it'll go away. Multiply by the denominator and it'll go away. And actually you'll wind up with point slope form. So just try to remember y minus y1 is equal to m times x minus x1. Another form is called slope-intercept form. And we've talked about this. We know that y is equal to mx plus b, where m is our slope and b is our y-intercept. And then the last one is standard form. And standard form we talked about also. Sometimes it's called general form, but very, very rarely. We are going to use ax plus by is equal to c. Now sometimes this is called general form, just so you know. And sometimes it's written ax plus by plus c is equal to 0. Now, I've only seen that a handful of times. In this class, we'll use the way that I told you up here. A few things I just want to point out. One thing is that a, the leading coefficient, is always positive. If it's negative, you could just multiply the whole equation by -1, and that would take care of that. Second thing is we're not allowed fractions, so let's say no fractions, or decimals. And for our equations to be in standard form, we want the x and the y on the same side. So the x always comes first. Those three things get you in standard form. So let's do some practice. Write the equation of a line through the point -4, 1 with a slope is equal to -3. Okay, well, let's do it in three different ways. We have our slope, we have a point, so maybe point slope form would be easiest. Now with point slope form, remember it's y minus y1 is equal to m times x minus x1. So it's going to be y minus our y1 value. Y minus 1 is equal to our slope times x minus -4. That would be point slope form. Now if we had to write it in slope-intercept form, one thing we could do is we could take point slope and rearrange it. We can just get the y by itself, or we could solve for it. So watch, I'll show you two different ways to do it. One way to get slope-intercept form is take our point slope, distribute the -3, and add 1 on both sides. So we get y is equal to -3x minus 12 plus 1 gives us y is equal to -3x minus 11. Another way we could do this, remember slope-intercept form is y is equal to mx plus b. Well, we have a y value from our point. We have a slope of -3. We have an x value from our point. The only thing we don't have is a b, or a y-intercept, which we could easily solve for. This would be 1 is equal to 12, and if we just use basic algebra, subtract the 12 on both sides, you'd get that b is equal to -11. So to tie it together, our slope and our y-intercept, you could see we get the same answer no matter which way we do it. I prefer the second way, but there's always, maybe 20% of the class that likes the first way better. And then the last form, let's get it in standard form. Now you can't just go from a point and a slope to standard form. You have to take one of the other forms and rearrange it. So we could take point slope, we could take slope intercept, it doesn't matter. Let's just take y is equal to -3x minus 11. We want the x and the y on the same side, so I'm going to add 3x to both sides. And I get 3x plus y is equal to -11. And that's standard form. A is positive. There's no fractions or decimals. And x and y are on the same side, so that's how we do a problem like that. I showed you 3 different forms. Let's do the same thing, but what if I asked you to write the equation of a line through -3, 2 and to -4. And what makes this one different is we don't have a slope. We use slope for all the different forms. So let's go ahead and figure out what our slope is first. I'm going to subtract the y's in this order. I'm going to put that over the x's, subtracted in the same order. And I get my slope is -6 over 5. All right, and let's go through what we did before. As far as our point slope form, we are going to say y minus y1 is equal to m times x minus x1. Well, we have 2 points, right? We only need 1, so pick whatever one you like better. This one is kind of standing out to me. So we have an x1 value and we have a y1 value. So we get y minus y1 is equal to m times x minus -3. That's a perfectly acceptable answer. Now what if you chose the other point? Y minus -4 is equal to m times x minus 2. It's totally fine too, right? So it doesn't matter which point you pick. If you rearrange this, either one, you would get the same slope-intercept form and the same standard form. Now for slope-intercept, we could rearrange them if you want. I'm going to do what most students do, and they solve for the y-intercept. So then let's use the point -3, 2. So I'll plug in -3 for the x value, -6/5 for our slope, and then 2 for the y value. Now we just have to solve for the y-intercept. So we get 2 is equal to 18/5 plus b. Now 2 is really just the same thing as 10 over 5. So 10 over 5 minus 18 over 5 gives us a y-intercept of -8 over 5. So in slope-intercept form, we would have y is equal to -6/5 x minus 8/5. Now, one other way we could do this is, instead of doing slope-intercept form by plugging in numbers and solving for the y-intercept, we could also just take one of our point-slope equations and just rearrange it. And if we add 2 and distribute the negative 6/5, we'd get y is equal to negative 6/5 x minus 18/5 plus 2, or plus 10/5. So you can see we get exactly the same answer that we got before. I just showed you a couple different ways to do it. And then finally, we'll get this in standard form. Standard form, remember, was ax plus by equals c. And usually we just take a slope-intercept equation and rearrange it. So let's go ahead and do that. We'll take y is equal to negative 6/5 x minus 8/5. First thing we could do is get rid of the fractions. We do that by multiplying by our LCD of 5. So we get 5y is equal to negative 6x minus 8. And then we could get the x on the same side with the y, and the x always comes first. 6x plus 5y would equal negative 8. Now the c value could be negative, but a has to be positive, there's no fractions or decimals, and the x and y are together. Let's move on to the next type of example. What if I asked you to find the slope and y-intercept of 4x minus 3y is equal to negative 10. Now, if you remember, we did learn a shortcut on this. We said that in general, if we have an equation in standard form, which is what this is, we rearrange this so we get slope-intercept form. We'd get that y is equal to negative a over b x plus c over b. So if you could remember that, I mean, just looking at this, we know what our a is, this is our b, and this is our c. So I could tell you that right off the bat, our slope would be the opposite of a over b, negative 4 over negative 3, which is 4/3. And our y-intercept would be c over b, c over b. So that's pretty easy. But if you'd rather not memorize things, that's okay. We could just take our standard equation and convert it to slope-intercept form. So let's bring the 4x on the other side. We get negative 3y is equal to negative 4x minus 10. Divide everything by negative 3. And it's not a big deal. We get the same answer. Y would equal 4/3, x plus 10/3, and you could see our slope and our y-intercept are exactly the same as we already found. Let's move on to parallel and perpendicular lines. Now, parallel lines look like this. Most teachers teach it like railroad tracks. And in order for lines to be parallel, they need to have the same slope. We also have what are called perpendicular lines. Now, perpendicular lines look like an upside down T, or I mean, they could be a T like this. I mean, bottom line is they cross at a right angle. And in order to get perpendicular lines, we need two things. We need a slope that is opposite, and the second thing is they need to be reciprocal. And remember, that word reciprocal just means that we switch the top and bottom of the fraction. So for example, if one line had a slope of 1/3, the other line would have to have a slope. Okay, so take the opposite sign, that's a positive number, 1/3. So this is going to be a negative number, and then switch the top and bottom. Those two lines would cross at a right angle. So now let's do a problem like this. Let's say we're going to write the equation of a line passing through three, 5, and we'll do two parts. Part 1 is it's going to be parallel to the line 2x plus 5y equals 4. And then part B, it's going to be perpendicular to the same line. So we'll do it one step at a time. Well, if it's going to be parallel, we said that they have to have the same slope, right? We already have a point, we just need a slope. So you could use the shortcut I taught you, negative a over b, or you could just rearrange this if you want. And we get 5y is equal to negative 2x plus 4. We divide both sides by 5. We get y is equal to negative 2/5 x plus 4/5. So our slope would be negative 2/5. And because we want to write an equation parallel, we're going to use a parallel slope, which is the same thing. So we have a parallel slope and we have a point. So now we could go ahead and write the equation of a line. Now we have 3 different ways to do that, right? So using our point slope way, which was y minus y1 is equal to m times x minus x1. We could use y minus 5 is equal to our slope times x minus x1. That's a perfect equation that's parallel to what was given. For slope-intercept, we could solve for b if you want, or we could just rearrange point slope, whatever you want to do. Generally, people solve for b. So we would get the y value of our point is equal to our slope times 3 plus b. So 5 would equal negative 6/5 plus b. 5 is the same thing as 25/5. So 25/5 plus 6/5 is 31/5. So now we would get the equation y is equal to negative 2/5 x plus 31/5. To come up with our equation in standard form, what we could do is take our slope-intercept equation and rearrange the variables and make sure we get rid of any fractions or decimals. So we get negative 2/5 x plus 31/5. Let's get the x on the other side, so the x and y are on the same side. We have 2/5 x plus y is equal to 31/5. Our least common denominator is 5, so we can multiply each term by that. We get 2x plus 5y is equal to 31. And that gives us our standard form of an equation that's parallel to 2x plus 5y equals 4 through the point 3,5. So let's finish up by talking about the perpendicular line to what was given. So I'm going to ask you to, for part B, to find the 3 equations of a line that are perpendicular to 2x plus 5y is equal to 4, but the lines are going to go through the point 3,5. Now what we would do in this case is we would find the slope, just like we usually do. We already found it, but we could find it again. The easiest way to do this is to get the y by itself. So 5y is equal to negative 2x plus 4. Divide everything by 5. And you'd get y is equal to negative 2/5 x plus 4/5. Now the slope of this line is negative 2/5. So the parallel slope would be negative 2/5, which we used in the last example. But because this line is going to be perpendicular, we want to take the opposite sign. So because it's negative 2/5, we're going to make it positive, and then the reciprocal of 2/5 is 5/2. So we're going to be using this slope and this point and coming up with our three different equations. So first, let's do our point slope. Remember, point slope form is y minus y1 is equal to m times x minus x1. So this would give us y minus y1. So we have our x1 and our y1's values. So y minus 5 is equal to our slope. The perpendicular slope was 5/2 times x minus x1. This was our equation in point slope form. Now let's work on slope-intercept form. In slope-intercept form, remember it's y is equal to mx plus b. So our y value, we're going to use our point, which was 5. Our slope was 5/2. The x value of the point was 3. So we get 5 is equal to 15/2 plus b. And if we subtract 15/2 on both sides, 5 is the same thing as 10/2. So 10/2 minus 15/2 is negative 5/2. That's our b value. So the equation in slope-intercept form that's perpendicular to 2x plus 5y is equal to 4 through the point 0.35 is y is equal to 5/2 x minus 5/2. Okay, and then to finish this up, let's do our standard form. Standard form, we're just going to take our slope-intercept form and rearrange it and make sure we get rid of the fractions. So y is equal to 5/2 x minus 5/2. Let's bring the x on the other side. So this would be negative 5/2 x plus y is equal to negative 5/2. And our LCD would be 2, but remember we want our leading coefficient to be positive. So we can multiply by 2 and then multiply by negative 1, or we could just multiply by negative 2, and that'll make our leading coefficient positive, and it'll get rid of all of our fractions. Okay, so thank you very much for your attention. Please stay tuned for our next section.